Just one little bit today. It's also on trig integrals, but I just leave it to by itself because it's just specifically looking at using t results. So remember, if t represents tan x on 2, then sine x is 2t on 1 plus t squared, cos x is 1 minus t squared on 1 plus t squared. Tan x, of course, is 2t on 1 minus t squared, but we don't tend to use that. It's the sine and the cosine ones we tend to use in these questions. And the derivative then, if I'm going to use t is equal to tan x on 2, then dt dx will be a half sec squared x on 2. Sec squared I can rewrite as 1 plus tan squared x on 2. And so we get a half of 1 plus t squared. But that also is like a t result. We don't have to derive that every time. So the t result for this substitution is dx is 2 dt on 1 plus t squared. So it's for this sort of question. Obviously the substitution I'd like to do would be u equals cos x, but I don't have a sine x anywhere to substitute into. So this is where the t results will become useful because I can turn this into a polynomial by making it a t result. So I'm going to use t equals tan x on 2, so dx will be 2 dt on 1 plus t squared. Sub that in, and the nice thing about the t results, of course, is the denominator always turns out to be the same. So we can multiply everything by 1 plus t squared to eliminate the idea of fraction on fraction. And I just end up with a quadratic denominator to deal with. And in this case, it's a nice easy one. It just turns out to be inverse tan. So I've ended up with 2 dt on 13 plus t squared. So that's 2 on root 13, the inverse tan of t on root 13. The last thing to do, of course, then is to substitute back in for the t. And so 2 on root 13 inverse tan of tan x on 2 over root 13 plus a constant. Now, I don't have to make t equal to tan x on 2, but it's all just to do with double angles. So I could say t is equal to tan x. Now, if that was the case, look what happens to my dt. Right? Dt dx is now 1 plus t squared. So dx becomes, instead of 2 dt, it's now dt on 1 plus t squared. Okay. So basically what happens is if you make t equal tan x on a, okay, going through the calculus of it, you will always end up with a dt on 1 plus t squared. So our standard one of x on 2 ends up 2 dt on 1 plus t squared. But if I decide to make it in this case, it was x on 1, then it was 1 dt on 1 plus t squared that I'll substitute in for dx. See? Ooh, look, A's match. There we go. So that's all I really want to talk about with that one. Just a handful of others to try using the t results.